I'm Chaim Goodman-Strauss, and I've been involved with discrete geometry and tiling and a number of associated subjects for most of my career. So much of what I've done in the past has to do with tiling in general, so questions about what a shape can do when it fits together, and that naturally it comes from recreational mathematics and discrete geometry, but it has a lot of connections to the foundations of logic, to questions of decidability, and to all sorts of other things. But then in the last few years, the area's really opened up, and so this conference that we're at has a lot to do with basically playing the same kinds of games on geometric groups, on groups, but viewed as So I think for my whole mathematical career, even when I was a student, even when I was maybe a child, I was interested in trying to touch the mathematics and try to find some simple truth that I could latch onto and understand, and to certainly embrace the complexity and abstraction, but also to seek some simple kernel of truth within things that might be accessible. So largely what I do, apart from being a mathematician, but as a mathematical educator or really a mathematical artist and illustrator, is to find ways to take what have been seen as abstract or difficult or not real world types of mathematics and bring them into reality. So for example, here's a little piece of the hyperbolic plane, like literally a piece of the hyperbolic plane. These are literally horocycles. Okay, it's not literally a piece of the hyperbolic plane because it's finite, but it's good enough. And so this is, of course, related to some other models, physical models of the hyperbolic plane. But in general, it's really quite difficult and subtle to throw things away, to figure out what do we need to hang on to, that if I want to explain something to someone who's not a technically trained, what are the core ideas that, and to me that's really exciting. And so I try to do that with my work. That's why I'm at the Museum of Mathematics. I try to share with children, actual, young mathematicians, many of them, just to give them some hint of the kinds of ideas that we work with and they can encounter. I would really like to encourage mathematicians, research mathematicians who might see this, to really think about how to take your work and to put it into reality in simple terms. I think that it's too easy and kind of a cop-out to say that that's impossible. It's just a matter really of thinking, okay, is there some simple heart that I can share with non-mathematicians? Possibly the answer is no. That's certainly the case for much the bulk of mathematics. But then on the other hand, I just ask that you think about it. So in the area for a long time, there have been this question of how simple how small of a set of tiles could emulate arbitrary computation, how it could carry out arbitrarily complex behavior. And this quest had been taken from thousands of tiles to hundreds but within a few years of the initial discovery of this area, which was in the 60s, there were already some fairly small sets of tiles. But then the question was, can you get it to 2? And that was solved. And finally, can you have a single tile like this one, the hat? And so the magic of the hat is that, copies of it can fit together, and forever you can fill out the entire plane, but it'll never quite repeat. So I think the interest in the area was just simply, we knew that we could do this with many different shapes. Can we do this at the same time, using them to play off of each other, but can we do this with a single shape? And so that was very exciting. It was something that was exciting to people in the area, but it also caught the attention of people around the world, perhaps just because it's easy to understand what the question was. So it's a rare piece of mathematics that is, interesting mathematically, but also accessible to the public. So that was pretty interesting too. As far as the general mathematical importance, well, I don't know. I'm a bit skeptical of that. I mean, there's a lot of related questions that still are related off of that, but I think we'll have to wait and see if there are any applications, any mathematical applications. The hat was discovered by Dave Smith, who is not a professional mathematician, but it's a real question. Is he a mathematician? Of course he's a mathematician. He had a very specific idea of where to look for this tile, and he searched for it and found it. He was doing this as a hobby, as something for his own pleasure and entertainment, which I think was probably necessary because for an academic position, it would be madness to try to find something like this. It was just, there was no reason to really expect that it would work, and did work. So Dave Smith, he's not in academia, but then he contacted a few of us with more training and just technical knowledge, and so then we put the result together. So it was really a collaboration between professional and non-professional mathematicians, which is pretty exciting. That's a really hard question because we're coming from a perspective where we already know it's beautiful, we appreciate it, and one of the things that's happened in the last 30 years or so is to try to use visual imagery or things that are more obviously aesthetically appealing to convince people that mathematics is beautiful. But I think that that's of limited value in some really fundamental sense. And I say that as somebody who's deeply involved with mathematical illustration and exposition. The true beauty of mathematics is something that I think you have to be maybe a mathematician to really enjoy, which is that you have all these interesting ways of putting mathematical structures together and understanding them, and the abstraction itself is part of the beauty. But nonetheless, mathematicians, I feel, have turned away from the concrete, that not enough of us practice concrete mathematics, and that can be much more appreciated by non-mathematicians and the general public. So I think that the hat, just on the terms of having a solid piece of mathematics that can be tangibly touched and the result can be explained, maybe that is or isn't indicative of what mathematics is like as practiced by mathematicians, but certainly it does a great job of showing people the richness and inherent subtlety and beauty of mathematics. I mean, for me, the beauty comes from being confused, from solving puzzles, from having mysteries to think about, and to use logic, mathematical logic, as a tool for understanding those things. And so maybe people got a taste of that with the hat. Well, first of all, Cirm is fantastic. I first visited here as a graduate student, and I've seen a lot of the changes before this room was built, and of course it's in such an amazing setting. It's just, I love coming to Cirm. Cirm is fantastic, and now that there's much more, I think Cirm has always had a very warm feeling, but now that there's so much mathematical art here and so much, I think, a renewed focus on mathematical exposition, to me that's very nice, and I think that will bring in lots of young people that may, in general, this trend will bring in a wider selection of young people into our area, so that's very, very good. As far as this meeting, this is great. This is the kind of thing that when I was 30 years ago, I was dreaming for, but the field didn't exist, and so I've been around long enough to see various kinds of disciplines, subdisciplines emerge and become mature. And the particular content of this week and last week at Cirm has been very interesting to me. In some sense, I really wish that they had been, I was one of the young people today, but that's not the way it works. So I'm very glad to have seen this area develop. This week we are celebrating the legacy and birthday of Jarkko Kari, who I'm about the same age, a little bit younger, and we really have been around watching this all develop. Jarkko has been instrumental with any number of important examples and pushing things in various kinds of directions, all sort of generalizing the idea of tiling, but into other kinds of somewhat more abstract realms. It still has a very concrete feel, at least to me, but it's substantially more abstract than where we started, which is just simply how actual shapes fit together in the actual plane. And so that's what we're... So the Klein quartic itself is a very well-known object that there's a beautiful book, which I must be in the Cirm library, called The Eightfold Way by Silvio Levi, or edited by Silvio Levi, that explains the Klein quartic in, I don't know, so many different ways. But fundamentally, to me, what it is could be viewed as basically like a Platonic polyhedron, like the icosahedron or the tetrahedron. Those live on a sphere. Those are essentially tilings of the sphere by regular polygons. Like a soccer ball, for example, is literally a tiling of the sphere with heptagons. I mean, it's hexagons and pentagons. And so the Klein quartic is living not on a sphere, but on a genus 3 surface, a surface with 3 tubes. I have to draw it. And so, but I wanted to, and there have been various kinds of ways of making it real. Various people have made sculptures and models and pictures of it in reality, but it always looks very distorted and strange. So the Klein quartic is covered with 24 heptagons, 24 heptagonal faces. It has this rich of, it's very, very symmetrical. Everything can be interchanged with everything else. But the drawings all made it look like a total mess. And so I'm really pleased with that. That's a brand new way of looking at this very old object, the Klein quartic, where you can more see the symmetry much more clearly. You can really see these heptagonal holes. And you just have to remember that opposite sides are actually glued together. And so incredibly, every band can be interchanged with any other band in the abstract thing, which is really hard to believe because some of them go like this, some of them go like that. But abstractly, they're all the same. So in rock bottom, it's like a Platonic polyhedron, a regular polyhedron, but on a multi-genus surface. And then my contribution is to render it in a new way, which I think is really cool.